All right, good afternoon, Algebra 2. 9.10, finally our last unit in this, or our last section in this unit. It's entitled Using Logarithms to Solve Exponential Equations. So, in previous lessons, so all along, you've learned to solve equations of the form b to the x power equals a, only by trial and error, and we used our calculator a little bit too, which is you're using graphs part. So in this lesson, we focus on the use of logarithms to obtain exact solutions to equations of this form. So make sure you write all of this down, because your process here is going to involve 3 steps. 1 is going to be taking logarithms with same base of each side. 2, we're going to apply the power property of logs. And 3, we're going to solve the resulting linear equation. So these seem complicated at first, but it really is these same 3 steps each time. So please make sure that you pause to write these down so we can actually use them in the next couple slides here. Okay, so the first example says solve 5 to the x power equaling 20. So 5 to what power gives you 20? If this was 25, we could easily answer with 2, but it's not. So we actually have to solve this by taking logs. Now you do get some choices here. You can take your common logs, which remember we're just log of base 10, so just log of whatever. And they also want us to do it by natural logs, which remember was natural log of whatever you had there. So we're going to do it both ways, and you get to choose which way you like better, because really, guess what? They're both going to work out. So our first step was to take the log of both sides. So now if I'm using log of base 10, I have to do it on both sides. So we have log base 10 of 5 to the x power equals log base 10 of 20. And this is perfectly legal because I did the exact same thing on the left as I did on the right, which is our fundamental rule of algebra. Okay. Now what I'm going to do is I'm going to take this side and I'm going to use my power property of logarithms. Remember, if I have a power out here, I can take this guy and put it outside, out front here. So we have x times log of base 10 of 5 equaling log base 10 of 20. Okay, so we have x times this stuff. So to get x by itself, all we would have to do is to divide by log of base 10 of 5 on each side. Log base 10 of 5 on each side, because that's going to get rid of it over here, and all I'm going to have left over is x. So I have x equals, and I don't need to write these base 10s anymore because it's our common log, so I'm just going to write log of 20 over log of 5. Okay, and then I actually have to figure out what that is, so I have no other choice but to grab this guy. So everybody get their calculators out. And this is why I chose to do common logs, because it's going to be something we're going to need to evaluate on our calculator. So I can't do anything but log of base 10 or natural logs on my calculator, so that's why we're doing log of base 10. So don't do log of base 4. That would not be very helpful here. So we just do log of 20 divided by, so we close our parentheses, and divided by log of 5. Close them again. And we hit enter, and we get x equals, and so now we're going to have to round, so approximately equal to 1.86. Okay, and that's as far as we need to go for my purposes anyway. So 1.86 is our answer there. There you go. Oh, well, that means, I guess let's check this. Sorry. That means that if I take 5 to that power, I should get 20 back out. And I don't use 1.86, you know, because that's been rounded, so do 5 to that power. So second answer, and we should get 20 back out. Excellent, which we do, so we're good to go. We can always check these, which is nice. All right, so that's about how you would do it by taking common logs. So let's go ahead and do natural logs now, which is going to work much the same way. I'm going to go back to my original equation and say natural log of 5 to the x power equals natural log of 20. I could do this either way, because the change of base powers here, when I would do my power property of logarithms, my goodness, it works for natural logs as well. So we write x times the natural log of 5 equals 20, natural log of 20, excuse me. And to get rid of this natural log of 5, we would just divide by it, because we're being multiplied right now. So divide by the natural log of 5. These get canceled out. We just have x left. So we have x equals the natural log of 20 over the natural log of 5. And this ratio should be the same as 1.86, but let's try it. Now we're using our natural log button. Natural log of 20 divided by natural log of 5. And voila, exact same number as what we got before. So x equals approximately 1.86. And we could always check by going 5 to the second answer. Should get 20 back out. And we're good to go. We know we did it right. Because both of these x's actually plugged back into this equation, 5 to this 1.86, we got 20. We know we are right here. So either way, if you use common logs or natural logs, either way you're going to get the right answer. Next example says, at what rate of interest compounded continuously would you have to invest your money so that it would triple in 10 years? So hint, use the compound interest model PERT, so our PERT equation here. So remember that was A equals PE to the RT power. And let's go ahead and plug in what we know. What rate would we have to invest your money so that it would triple in 10 years? Okay, so we don't know how much we put in. So let's just say we put in $1. Okay, that'll be the easiest for us here. And we don't know the rate. What rate of interest, that's actually what they're asking us. So we can say, all right, our rate here, we don't know. But we do know we have 10 years to triple it. So times 10 for our time. And then A should be, well, we put $1 in. If we tripled that, what would we get out? Well, we'd get out $3, of course. So we'd have $3 out here. Okay, so make sure we set up, we put $1 in to start because we don't know how much we're actually putting in there. And then if it triples, it gives us $3 out. That's what goes in for A. E is just E. And then R, we don't know what our rate is. That's what we're trying to find. Times 10 being our time, so 10 years here. Okay, so this 1 times E to the R to the 10th power, we could just say E and then 10R if we wanted to clean that up a little bit, equals 3. And then we're going to take the natural log of both sides. So natural log of 3 equals the natural log of E to the 10 to the R power. Okay, now I can say, alrighty, let's pull this out front using our power property here. So we would have natural log of 3, that stays the same. This comes out front, so 10R times the natural log of E. Now, if you notice, I have the natural log of E, which we know the E was to the exponent, and our natural log here, natural logs and exponentials undo each other. So let's actually see what we get when we try to take the natural log of E, and E to the first power, of course, because we only have one of them. So if I take the natural log of E to the first, those undo each other, and we just get 1. That should happen for you every time. So if you have the natural log of E, well, that can just be replaced with 1, which really, we'd have 1 times 10R, which would just be 10R. So we'd have 10R over here, natural log of 3, and then just to solve for R, we'd have to divide by 10. And so that would be gone over here, and we would have R equals natural log of 3 over 10. So now maybe, before I even give you the answer to this, maybe you're realizing why I chose to take natural logs. Well, anytime you're dealing with that number E, I would really advise solving them using natural logs versus common logs, because this will always be 1. The natural log of E will always be 1, and you can always just kind of ignore it in your problem once you've got it. So get out of here. We just care about the 10R. So anytime you have that natural log, or that E, you're going to want to use natural logs to solve. Will it work if you do it the other way? Sure. It's just going to be a little harder for you. Okay? So now, last step, we just need to figure out what natural log of 3 divided by 10 is. Let's grab our calculator. So natural log of 3, be sure you close your parenthesis here, and then you divide by 10, because that's what it wants you to do in your problem. And we get our rate is 0.1, let's round that to 1. So essentially that would be 11% here. Or if you wanted to be a little more precise, I guess that would be 1099. You could say 10.99%, but for me, it's good enough to have your 11% here. So change it to a percent because it is a rate, so you actually have 11%. So good luck finding an 11% savings account, because that's going to be rough. Typically they run about 1% or 0 point something percent. So if you can find an 11%, call me. I'll be very happy, because that's where I would want to invest my money. Okie dokie. I have another video for you because I have a couple more examples. So hang tight and join me for the next video.